Just talk about perimeter and area. So we're in section 5.3 is where this comes from, and we're talking about circumference and area of circles. So the first thing I want to do is talk about the definition of a circle. We'll do a little more work with the definition of a circle. With the definition of a circle a little later in the semester, but I just want to talk about it really briefly here because it really helps us think about what we're talking about. Circle is the set of all points in a plane, because circles are flat, that are the same distance from a center. So this is how we define a circle. This is what in technical language, technical math language, this is how we talk about a circle. All points that are the same distance from a center. For a circle, what do we call that distance? If we're talking about the center, from the center to the circle, what do we call it? The radius. That's the radius. So we call this distance is the radius of the circle. And what's another important part of a circle that has to do with something going through the center that we use? The diameter. So the diameter is another thing that we talk about with circles. How are the diameter and radius related? Radius is half the diameter. So the diameter I'm going to say is all the way across, and we'll draw a picture here in just a second. And I'm going to say that the diameter is 2 times the radius, which is the same as saying the radius is half the diameter. So the distance that we're talking about in our definition is the radius. The diameter is all the way across, and that's 2 times the radius. So let's draw our picture. Your picture's in the flip book, so we'll label some parts here. I want to make that a little bigger. So there's our circle that's in our flip book. Here's the center, and we'll label the parts. So I'm going to say that I'll do this in red. I'll do one in blue. Darn it. There we go. So this point here, this is our center. This is the radius. And this is the diameter. And we usually use R for radius. The diameter we usually use D. So the diameter is 2 times the radius, and the point right here in the middle is our center. And we've talked about circles. You've learned about circles in a lot of different places. So this is stuff that you've seen before. We just want to make sure that we're all on the same page here. So I kind of gave it away at the beginning, but with a circle we don't call the all the way around, we don't call it the perimeter. What do we call it on a circle? The circumference. Does anybody remember the formula for the circumference? How far it is around? What were you going to say? Pi times, you said 2 pi r, you said pi times the diameter. So either of those ways work. So let's write that. That's going to be our first formula. So the circumference is the distance around and we usually say that the circumference is 2 pi r, or the circumference is pi times the diameter. These two mean the exact same thing. And our units for circumference is a length, so our units are just going to be units. So it'd be inches, meters, miles, millimeters. So some kind of unit of length is going to be our unit for the circumference. Now, one of the reasons that circles are so cool, that I like being able to talk about circles, is this is really the first time that we get to talk about pi. Pi is a really special, really important number in math. Pi is a constant. And pi, if we write pi as a decimal, the decimals, the numbers go on forever without repeating. So I have up here in the red frame, I have pi written out, and the digits get smaller and smaller and smaller and smaller as it goes across the page. But computers, we've calculated computers, I think the last that I read is so many billions of digits. They've calculated the digits of pi on computers, and there's no repeat. So we know the digits of pi to so many billions of digits. What they do with computers is they program two computers to calculate the digits, and then they calculate and calculate and calculate until the two computers disagree. And then when those two numbers disagree, they say that's how many digits we know. And so the last that I remember, and this was a few years ago now, they've probably done more now, I can't remember how many billions of digits it was, but it was a lot. So we've calculated the digits of pi a long, long, long ways out. It doesn't repeat. Pi is really special because for any circle, pi is, if we measure the circumference of the circle and we divide by the diameter of the circle, we always get pi. No matter how big or small the circle is, no matter where the circle is in the universe, as long as we're on a plane, pi, if we divide the circumference of a circle by its diameter, we get pi. So it's a really cool idea. Pi shows up in lots of equations in science and physics, lots of different places where you wouldn't think it has anything to do with circles, but pi shows up. So it's a really important number. To me, it's like getting a peek into like the secrets of the universe. Pi, we have known about pi. Mankind has known about pi for a long, long, long time. In ancient Egypt, they knew that pi was about 3, and they were aware that it was a constant. In Egypt, it was important because in Egypt, geometry, measuring areas, first developed because they needed to keep track of who owned what pieces of land. So it was important to be able to find the area of the land that someone owned, that someone farmed, whatever. And when they had circular pieces of land, they figured out that this number pi pops up. There's a reference to the value of pi in the Bible that gets talked about a lot. So mankind, humans have been using and have been aware of this number pi for thousands of years. It's really it's really important, it's really cool, and to me it's a really, I don't know, the idea of pi and this relationship between the circumference and the diameter of a circle is really kind of special. So it's kind of cool that we can talk about it. So when we calculate, when we're working on circles, the questions will ask us sometimes to give an exact answer, or the other way they'll write the question is to give your answer in terms of pi. And what that means is we multiply everything out except the pi, and we leave pi in our answer. And we'll do an example here in just a minute. So just be aware that pi is this infinite decimal number, and the decimals never repeat, and it has this special property with circles. So let's look at a couple of examples working with circumference. Any questions about pi? All right. So let's say we have a circle. Our radius is 17 inches. So we'll start with an easy one. We want to find the circumference. So we're just going to plug our numbers into our formula. The circumference is 2 pi r. So I'm going to plug that in. Circumference is 2 pi times 17. Now for our exact answer, if the problem asks us for an exact answer or for an answer in terms of pi, what I'm going to do is multiply the 2 and the 17 and leave pi written in my answer. So I would write this as 2 times 17 is 34 pi inches. So this is my exact answer. I just multiplied all the numbers and left pi there. The reason this is an exact answer is when I write the symbol pi, that is the number with all the infinite decimals. So we haven't rounded it at all. This includes all those infinite decimals that are after the decimal point. So this is an exact answer. If we wanted an approximation, then I would, in my calculator, I would multiply 34 by 3.14. Or if your calculator has a pi button, you can use the pi button. And we get approximately 106.81 inches. And this would be rounded to the hundredth when we round it to places. So our questions will ask us in two different ways. One will say, give us an exact answer or an answer in terms of pi. That's what this means. We just multiply everything out and leave pi there. An approximation is when we just multiply by, in our calculator, we multiply by our number. Questions on that example? Yeah, the problem will say give an exact answer or round your answer to 2 decimals. If it doesn't tell you, then I would take either one. I would take either one if it doesn't tell you. Okay? Let's look at an example where we go the other way, where we know the circumference and we want to find the diameter or the radius. So let's say the circumference equals, and I'm just making this up, equals 183 centimeters. We want to find the radius of this circle. So when we have the circumference and we want to find the radius or find the diameter, we plug everything into our formula and solve for the part that we don't have. So I'm going to write my circumference. I know the circumference equals 2 pi r. So I'm going to write the circumference is 183, so 183 equals 2 pi r. I'm trying to get the radius by itself. So what do I have to do to get the radius by itself here? Divide, what's the 2 and the pi doing to the radius? Adding, subtracting, multiplying, dividing? It's multiplying, so we have to undo that by dividing. So we're going to divide both sides by 2 pi. When I divide this side by 2 pi, these cancel. This just gives me 1. And I get that r equals, and in my calculator, I'm going to divide 183 by 2, and I get 91.5 divided by pi. This would be my exact answer. I divided the numbers and I left the pi there. That's my exact answer. And my units would be centimeters. So 91.5 divided by pi centimeters would be my exact answer. If I divide 91.5, divide that by 3.14, I get that it's approximately 29.14 centimeters. And that's my approximate answer. And I got that just by dividing 91.5 by 3.14. So that's my approximate answer. Exact answer, approximate answer. Exact just means don't just leave the pi where it is and multiply or divide the numbers. Questions on that example? I just divided by 3.14. Yep. All right, let's talk about the area of a circle. And I think we probably all know the formula. The area is pi r squared. And you've heard the old joke, right? About cake r squared, pi r round. So the area is pi r squared. Our units for area. Our units are always units squared. So it's going to be square centimeters, inches squared, meters squared, miles squared, some kind of squared unit. Square, some square. So what we're talking about, the reason we talk about square units is we're saying how many tiny little squares can we fit inside the circle. That's what area really means. So if we're talking about square inches, how many little squares that are an inch by an inch could we fit inside that circle? So that's why that's kind of funny to talk about square and circles at the same time, but that's what we're talking about. So this is an easy formula to remember. So let's look at a couple of examples of working with the area formula. So here's my first one. We'll draw a picture for this one. Here's my circle. And this is 17 centimeters, and we want to find the area. So what do we need to do here to find the area? You have to start with the radius. Our formula has a radius. So the radius, how are we going to find the radius from what we have? 17 divided by 2. Cut that in half. And when we divide 17 by 2, we get half of 17, 8.5 centimeters. So now we can just plug this into our formula. The area is pi times 8.5 squared. If I want an exact answer, I'm just going to square 8.5. In my calculator, I'll square 8.5, and I get 72.25, and I'm going to leave pi there. And my units are going to be centimeters squared. So this would be my exact answer, or my answer in terms of pi. That would be my exact or my answer in terms of pi. If I want an approximate answer, I would say area approximately equals, I would multiply 72.25 by 3.14, and I would get that the area is about 226.98 square centimeters, and that's my approximate answer. Questions on that example? So, a lot of times students get confused when we say exact or in terms of pi. All that's telling us is do everything with the numbers and leave pi wherever it is in our answer. That's all it means. Approximate means multiply by 3.14 or whatever we're using for pi. All right, let's look at an example going backwards from the area and finding the radius of a circle. So we're going kind of the other direction. Let's say the area, and I'm just making this number up. So the area of a circle is, let's say it's 327 square inches. We want to find the radius. So when we have a problem like this where we have the area, we're going to plug what we know into our formula and solve for the part that we don't know. So we know that the area is pi r squared. Our area is 327, so I'm going to say that 327 equals pi r squared. Now we're trying to get to the radius. What do we have to do to get this pi away from r squared? We have to divide. It's multiplying, so we have to divide. So I'm going to divide everything by pi. Pi divided by pi just leaves me with 1, so those go away. So I get r squared equals 327 divided by pi. How do I undo this square? Square root. So if I take the square root of both sides, I would get that r equals the square root of 327 divided by pi. I guess this could be our exact answer. Usually when we get a problem like this, we'll want an approximation. So I'm going to plug this into my calculator. 327 divided by, I'm going to use 3.14. So I get this equals the square root of 104.14. 0.14. And when I take the square root of that, I get 10.2. So the radius is about 10.2, and our radius is a length, so it would just be inches. So when we need to find the radius, when we know the area, when we need to find the radius, we just plug what we have into our formula and solve for the part that we don't know. What if we wanted the diameter of the circle? What would we do? We figured out the radius. The radius 10.2. What's the diameter? Times it by 2. Right. That's all we have to do to find the diameter. So if the problem had asked us to find the diameter isn't in our formula. The radius is in our formula, so we can find the radius and then multiply by 2. couple of things to look out for in the homework, and then there's one last little thing that I want to talk about. Some of the problems ask you in the homework, they'll ask you to use, it'll say use 22/7 for pi. 22/7 is a pretty good approximation of pi. So if I put in my calculator 22 divided by 7, 22 divided by 7 is 3.14286 about. So that's pretty close to the actual value of pi. So some of the problems will say use 22/7 for pi. So you're going to use all it's asking you to do is use the fraction 22/7 instead of the symbol pi. It's 22/7 is one of the approximations that I think they may have come up with it in Egypt. It's just one of the ways to approximate pi. Just a convenient number to use for pi. And in Europe, they do the dates the opposite from the way we do. They do the day and then the month. So we celebrate Pi Day on March 14th, 314. They celebrate Pi Day on July 22nd, 22/7. So they think we do it wrong, and we think they do it wrong. But they use the 22nd of July for Pi Day in Europe and England. July 22nd is Pi Day.
Are we going to have Pi Day here?
Yeah, because Pi Day usually comes around CSAP days, so we do a Pi Day. And last year you should have seen all the food we had. It was amazing. All right. The other thing that I wanted to mention about the homework is you will get problems, some problems where they say, and I just want to think about it here for a second. Say we had a square, and inside the square we had a circle. And the problem, let's say the problem asks us to find this area that's inside the square but outside the circle. How would we find the area inside the square but outside the circle?
You would find the area of the circle and the square, and then you would take divide the area of the square with the circle.
So we want to find the area of the square. So I'm going to write that as the area of the square. We want to just subtract, right? We're going to take away the area of the circle. So we're cutting this part out. So in little shorthand, I'm going to say the square minus the circle. So you just subtract the area that's inside. So some of the problems in your homework will ask you, they'll give you a shape inside another shape, and they'll say find this area. To do that, you find the areas of the two shapes and you subtract. All right. The next little thing I want to talk about is, it's not really, it's related to what we're talking about. It's not something that's going to be in your homework. It's just a nice way to think about where the formula for the area of a circle comes from. So I just want to show this to you. So this doesn't really need to be in your notes. I just wanted to show it to you because it's a nice thing, and I'll go a little further in just a second. Where the formula comes from. So if you go on in math, the argument that we use here, the process that we use to come up with the area of a circle, you'll see a lot. This is really the way that we work, figuring out things in calculus. So what we're going to do, and they came up with this idea in ancient Greece. A gentleman by the name of Eudoxus came up with this method. So what we're going to do is take this circle, and I'm going to divide it into little pieces. So what I'm doing really is cutting up my, if I think of this as a pie, I'm cutting out pieces of pie. I'm going to go all the way around and cut out pieces of this the circle, and I know I didn't get that center right in the middle. But. So I'm going to divide my circle into these pieces. What kind of shape do these wedges look like? Pizza. So if I cut these edges off, if I cut this off, I would have triangles. I'd have a bunch of triangles. So if I figured out the area of all these triangles, I would be pretty close to the area of the circle. The only difference would be this little piece outside the curved part. Now what we're going to do, the idea here is, if I look at this big wedge here, the outside of that triangle is pretty curved. So if I divide it into big triangles, I'm going to not be very close to the area of the circle. But if I divide it into a bunch of tiny little triangles, so I'm going to take this piece and I'm going to divide it into a bunch of triangles. So I'm going to divide this into a bunch of triangles, and now if I cut the edges off of the curved parts off here, I'm going to be pretty close. So if I divided the whole circle into these tiny little triangles and added up all the areas, I would be pretty close to the area of the circle. Now what I'm going to do is take these triangles out of the circle, and I'm going to arrange them in this nice way. So I'm going to arrange them. So I'm going to put one here, and we're imagining that these are tiny, tiny little triangles. And put one there, and one there, and one there. So I'm going to arrange them one right next to each other. And I'm going to keep going for as many triangles as I have in my circle. So I'm going to keep going because I've divided the circle into a whole bunch of pieces. One more. Oops. Make that about. Well, if I had a bunch of tiny, tiny, tiny little triangles and I put them all together, what does this shape kind of look like? Kind of looks like a trapezoid. What if I put another triangle on? It's pretty close to a rectangle. Well, what part of the circle is this side of the triangle? If I cut this out, what part of the circle is that side of the triangle? That's the radius. So the height of my rectangle is going to be the radius. And we said that all of these pieces around the outside, we're putting the triangles all together. All of the flat pieces of the triangle would add up to the circumference of the circle. Well, I have half the flat pieces up here and half the flat pieces down here. So this one side of this rectangle would be half the circumference, or pi, times the radius. How do I find the area of a rectangle? Base times height. If I multiply the base times the height, I get pi r times r, or pi r squared. So the idea for this formula for the area of the circle comes from dividing the circle into a bunch of tiny little triangles and adding the areas of those tiny little triangles together, and that's where this formula comes from. This method, this idea of dividing shapes into tiny, smaller shapes, is called the method of exhaustion. And like I said, in ancient Greece, Eudoxus came up with this idea, and they used it a lot. And the idea eventually became what we do in calculus. In calculus, if we go further in math and study calculus, we divide shapes into tiny, smaller shapes and add them together. We do that all the time in calculus. That's one of the basic ideas of calculus. So I just wanted to show you this because I think it's really interesting. It relates to something that we've already done, the area of a rectangle and areas of triangles, and we can come up with this formula for the area of a circle. Questions? All right.